Hey everyone, my name is Mukul and welcome back to the LangChain by Project series, proudly brought to you by NIIT. Today is episode 7 and honestly, this one is super practical. We're building a smart document extractor, a small tool that can read any text or PDF you drop in and turn messy text into clean, structured data you can actually use. Think about the kinds of things you usually wrestle with: contact details from a bio, a short resume summary, or named entities like people, companies, and locations inside an article. That's what this app is for. And we're using Llama 3, LangChain, and Streamlit to build this. And yes, everything runs fully locally on your machine. That means no API keys and no cloud. So if episodes 3 is about chatting with PDFs, this is about extracting real, reusable data from documents. Before we jump into code, a quick idea in 60 seconds. Up until now, we've built question-answer style apps, but a lot of real work is extraction. Pull the candidate's name, email, and skills from a resume. Pull people and company names from a news paragraph. Grab entities from a legal clause. These tasks need structured output, not just a paragraph. The pattern we use here is simple. We define a schema with Pydantic, ask Llama to fill it, use LangChain's PydanticOutputParser to force real JSON, and then show it nicely in Streamlit. Alright, now let's move into the code. At the top, we import Streamlit for the UI and PyPDF for reading PDFs. Then we import Pydantic for our extraction schemas and chat Ollama plus LangChain prompt and parser helpers to talk to the local Llama model. Then I set the model name to Llama 3.23b. Now let's build the brains, the schemas. First, we create a contact info model with fields like full name, email, phone, and company. Then we make a resume summary model with full name, current role, experience years, and a skills list. And finally, a general entity extraction model with lists for persons, organizations, locations, and key terms. These three modes cover simple contact extraction, resume style extraction, and generic entity detection, which is exactly the set of capabilities we want. Next, we add a tiny PDF helper called extract PDF text. It just loops over every page in the PDF and pulls out text. Nothing magical, just a small utility so users can upload resumes instead of copying and pasting text. Now we wire the schema selection. There's a getSchema task function that maps the drop-down choice to the right Pydantic model and the right instructions. If the user picks contact info, we return the contact info model and a short instruction like extract clear contact details. Don't guess missing values. For resume summary or entity extraction, we return the corresponding model and tailored instructions. This makes the app dynamic, with one UI, multiple extraction behaviors. Then we set up the model and prompt. We create LLM variable and we set the model name and set the temperature to 0.1. I keep the temperature low so the output stays deterministic and grounded, which is what we want for structured extraction. Then we build a chat prompt template that gives the model some extraction rules, some task instructions, and JSON format instructions like you are an extraction assistant and your task is to extract structured information exactly according to the provided JSON schema. And there are some rules like no hallucination and only fill fields that appear in the text. Then we jump to front-end side where the Streamlit UI is simple and clean. The title says episode 7, Smart Document Extractor, and there's a drop down with three options: contact info, resume summary, and entity extractor. Below that, the user can either upload a PDF or paste text manually. And if a PDF is uploaded and the text box is empty, the system automatically extracts the PDF text and show it in the text area so you can edit it before running extraction. And when the user clicks extract information, the system first checks if there's text to analyze. Is not, the system will show one warning. Then we call getSchema to load the right model and instructions. Then the system generate the format instructions using the PydanticOutputParser. And after that, system invoke the LLMs with the text, the instructions, and the format instructions. And if the extraction works, we show a success message and render the final structured JSON using stJSON. And if something fails, we show an error, no silent crashes. Now that the code, let's open the terminal now to install all the libraries need. Let me just write the command pip install Streamlit, LangChain, LangChain Community, LangChain Core, Pydantic, and PyPDF. And now enter. After installing all the libraries, make sure you pull the Ollama model using the command Ollama pull Llama 3.23b. And after pulling the model, let's run the program quickly. Alright, so this is the final app in action. What you're seeing here is the Smart Document Extractor running locally on my machine. At the top, we've got the title, Episode 7, Smart Document Extractor. And just below that, a one-line description explaining that this app extracts structured data from documents using Llama 3 and LangChain fully offline. Now the first thing I want you to notice is this drop-down here. This single drop-down controls the entire behavior of the app. Right now, it's set to contact info, which means the model is only looking for things like names, emails, phone numbers, and company details. But if I switch this to resume summary or entity extractor, the logic completely changes. Behind the scenes, a different schema and a different set of instructions are sent to the model. So even though the UI stays the same, what the model is extracting is totally different. Just below that, we've got two ways to give input. I can either upload a PDF like a resume, or I can paste raw text directly into this field. If I upload a PDF, the app automatically reads it, extracts the text, and places it here so I can quickly review or edit it if needed. Once the text looks good, the workflow is simple. I click extract information, and the model takes care of the rest. And instead of giving us a paragraph like a chatbot would, the output comes back as clean, structured JSON. Each field is clearly separated, nothing is guessed, and if a value isn't present in the document, it's simply left out. And yeah, that's it for episode 7. Today, we built a smart document extractor that turns raw text and PDFs into clean, structured data, all running locally with Streamlit, LangChain, and Llama 3. No APIs, no cloud, just a solid real-world extraction pattern you can actually reuse. In the next episode, we'll start connecting these pieces into bigger workflows and see how extraction fits into real products. Thanks for watching, and I'll see you in the next episode.